Please welcome to the stage Dr. Sue J. Liu, President of the National Academy of Engineering.
All right, good evening, and again, welcome. Tonight, we celebrate the accomplishments of one engineering pioneer, Dr. Eric Fossum, for innovation, development, and commercialization of the complementary metal oxide semiconductor, or CMOS, active pixel image sensor camera on a chip. Eric, we are so honored to have such a gifted engineer in our presence tonight as we recognize your remarkable impact on modern imaging. Now, I would like to introduce our special guest, Mr. Bo Willeman. Mr. Willeman is an acclaimed screenwriter, playwright, and producer. He is the creator of and showrunner of Netflix's House of Cards, earning Emmy, Golden Globe, and BAFTA awards nominations, along with a Peabody Award. He went on to create Hulu's The First, wrote on both seasons of Andor for Disney Plus, and served as executive producer on season 2 of Apple's Severance. On the big screen, he co-wrote The Ides of March, adapted from his play Farragut North, receiving Academy Award, Golden Globe, and BAFTA nominations. And he later wrote Mary Queen of Scots. He is also a former president of the Writers Guild of America, East, and co-founder of Westward Productions. Please join me in welcoming Bo Willeman.
Good evening. It is an honor to be here tonight and a privilege to present the Charles Stark Draper Prize for Engineering to Dr. Eric Fossum. I come from the world of film and television as a writer and a producer, a field built on storytelling and performance. Like so many creative industries, everything we do rests on a foundation of engineering innovation. Artists thrive on innovation. Technological advancements allow us to expand the potential of our artistry by improving both the quality of and access to the tools needed to employ our craft. Eric Fossum's CMOS invention, also known as the camera on a chip, fundamentally changed how stories are captured and shared. Before this technology, high-quality imaging required large, expensive, power-hungry equipment. Cameras were heavier, less flexible, and often inaccessible outside major studio environments. CMOS helped change all of that. They made cameras smaller, more affordable, more mobile, and vastly more energy efficient. That shift transformed how filmmakers work. It enabled lightweight digital cameras on sets, drones out in the field, new shooting styles, and unprecedented creative freedom. It also made it much easier for storytellers around the world to pick up a device, capture a moment, and reach an audience. In the world of cinema especially, this technology reshaped production. It allowed crews to move faster and with more flexibility, and to film with an unprecedented level of intimacy, whether it be a large-scale production, a low-budget indie film, or on-the-ground journalistic reportage. I can speak from experience on all fronts. Specifically, during the last several years, I've made many trips to Ukraine to film a documentary there. Without small, cinema-quality, highly mobile cameras, that work would have been impossible. Dr. Fossum's important work is one of the rare breakthroughs that changes the language of storytelling itself. What began as an effort to help NASA explore space now powers the way we explore human experience on screen. From the first cave paintings humans made by firelight tens of thousands of years ago, all the way to the films and television shows that now illuminate our screens, our species has strived to tell the human story as fully as our tools allow. Dr. Fossum has given us new tools to continue this ancient and noble endeavor. That is the remarkable reach of engineering at its best. It expands what is possible across disciplines. And in this case, it helps us tell the human story in ways that we never could have before. Dr. Fossum, on behalf of storytellers everywhere, thank you.
Thank you, Bo, for those thoughtful remarks and for highlighting the remarkable reach of engineering at its best. Now, for a few words on the Draper Prize, please join me in welcoming Ms. Amy Hart, Vice President of Contracts at Draper.
Good evening. My name is Amy Hart, and I'm the Vice President of Contracts at Draper. For the engineers in the room, Contracts delivers the business deals that fund your research projects. We are your silent partners and often your biggest fans, feeling a shared sense of pride in your technical achievements. It's my pleasure to be here today to share a little bit about Draper and the great work we continue to do since our founding father, Charles Doc Stark Draper, started the laboratory. Doc Draper was a serial innovator, expanding and refining his understanding of inertial guidance and applying it to increasingly advanced navigation systems for aircraft, ballistic missiles, and submarines. Not much has changed at Draper since our founding. Currently, our company embraces innovation as the process of creating and implementing new or improved ideas that generate value, solve problems, and introduce positive change, moving beyond mere creativity to real-world impact. We are honored that innovators like Eric Fossum are continuing in the footsteps of our founding father and bringing the value of innovation to our society and the world. Dr. Fossum's work at the Jet Propulsion Lab sought to improve upon existing image sensor designs by incorporating new technologies and design modifications. These efforts led to a CMOS active pixel image sensor that, through further refinement, eventually became the industry standard. CMOS image sensor technology is now used in almost all cell phone cameras, as well as devices for manufacturing and scientific imaging, medical instruments, and automotive safety systems. It's estimated that more than 7 billion CMOS image sensors were shipped worldwide in 2024. After leaving JPL and contributing to the commercialization of CMOS image sensors, Dr. Fossum continued to innovate by applying his knowledge to the development of 3D and photon counting image sensors that enabled high-resolution imaging in extremely low light conditions. His innovations have produced dramatic improvements in what active pixel sensors can deliver and brought digital imaging to the masses. The wide range of applications for his technology and its impact on society are profound and clearly worthy of recognition. On a personal note, I appreciate the timing of his innovations, allowing me to get through the antics of my youth without the widespread availability of this technology in everyone's pockets so that I could be here today. On behalf of the entire Draper community, I'd like to personally congratulate Dr. Fossum for earning the 2026 Charles Stark Draper Prize for Engineering.
Thank you so much, Amy. And again, special thanks to Draper for creating this prize. What began as a vision has become just one aspect of the legacy of Charles Stark Draper. Let's take a look at the legendary engineer behind this prize, Doc Draper, and Dr. Eric Fossum, who is being honored with this year's Charles Stark Draper Prize for Engineering.
The Charles Stark Draper Prize for Engineering was established by the National Academy of Engineering and endowed by the Charles Stark Draper Laboratory, incorporated in 1988 to honor the memory of Doc Draper, the father of inertial navigation, and to increase public understanding of the contributions of engineering to the freedom and well-being of humanity. The prize recognizes engineers responsible for technological developments that have transformed modern life. Doc Draper was an educator who trained generations of students at MIT. His belief that education needed a hands-on component led him to establish the instrumentation laboratory within MIT's aeronautics department. In 1973, MIT divested the laboratory. thus creating Draper, an independent, not-for-profit engineering solutions company. The Draper Prize acknowledges working solutions rather than theoretical discoveries. Examples of past winners include the developers of controlled drug delivery systems, creators of the GPS, inventors of the cell phone, innovators in wireless communications, and pioneers of personal computers and the internet. Without these remarkable engineering achievements, much that we take for granted in our day-to-day lives would not exist. The 2026 Draper Prize is awarded to Dr. Eric Fossum. Every day, billions of tiny eyes open to the world. They see our families, our lives, our planet, our universe. From the farthest galaxies to the smallest cells inside the human body, all captured through one innovation. The same technology that explores space also helps us look within. But this technology wasn't always possible. In the early 1990s, at NASA's Jet Propulsion Laboratory, engineer Eric Fossum faced a challenge. How could cameras be made faster, smaller, and tougher, using less power, costing less, and surviving the radiation of space? His idea was simple, yet revolutionary. To combine the best of CCD, charge-coupled device imaging technology, and CMOS, or complementary metal oxide semiconductor microelectronics, to create a camera on a chip, tiny, efficient, and powerful enough to go anywhere. That idea became the CMOS image sensor, a breakthrough that made it possible to see the universe through silicon eyes. Today, those silicon eyes are everywhere. In telescopes orbiting space, in rovers exploring Mars, in endoscopic tools that help doctors save lives, in drones that map disasters, in Hollywood cameras that bring movies to life, in homes and vehicles to help keep us safe, and in smartphones that connect us to one another. Every moment, every day. Technology has always mirrored human nature. Our desire to see, to understand, to connect. And through Eric Fossum's innovation, the camera became smaller than the human eye and significantly more sensitive. From pixels, people, and planets to infinite possibilities, Eric Fossum's vision reshaped how we see the world and how the world sees itself. Congratulations, Dr. Fossum, on your amazing career and on being awarded the 2026 Draper Prize.
That's wonderful. The Charles Stark Draper Prize for Engineering honors the engineers behind the world's most significant engineering innovations. To date, 61 engineers have received this honor. Tonight, we add one more to that distinguished list. I would now like to introduce my colleague, Dr. Alton Romig, Executive Director of the National Academy of Engineering, to introduce Dr. Eric Fossum.
The recipient of the Draper Prize receives a $500,000 cash award, a commemorative medallion, and a certificate. The recipient of the 2026 Charles Stark Draper Prize for Engineering is, as you've heard, Dr. Eric R. Fossum. He is being recognized for innovation, development, and commercialization of the complementary metal oxide semiconductor, or CMOS, active pixel image sensor, the camera on a chip. Eric is a pioneering semiconductor device physicist and engineer whose invention transformed modern imaging. He is the inventor of the CMOS active pixel image sensor, as I said, often called a camera on a chip, originally developed for miniaturization purposes for NASA spacecraft. The technology made high-quality imaging smaller, faster, and more energy efficient. Today, it powers billions of cameras worldwide, from smartphones and video communications to medical imaging, automotive safety systems, and space exploration. Dr. Fossum is the John H. Kriebel Senior Professor for Emerging Technologies at Dartmouth's Thayer School of Engineering, where he teaches, leads research in image sensors, and directs the PhD Innovation Program. He also serves as Dartmouth's Vice Provost for Entrepreneurship and Technology Transfer. His breakthrough invention, as you heard, emerged from his work at NASA's Jet Propulsion Laboratory, and he later co-founded Photobit to commercialize the technology. That work remains the foundation of roughly 7 billion cameras produced each year. More recently, Eric developed the Quanta image sensor, enabling high-resolution imaging in extremely low light conditions, and co-founded GigaJot to bring it to market. A member of the NAE and an NAE Council member, Fossum's honors include induction into the National Inventors Hall of Fame, the Queen Elizabeth Prize for Engineering, and the National Medal for Technology and Innovation. Notably, CMOS cameras based on his invention flew aboard NASA's 2020 Mars Perseverance mission on the rover and on the Ingenuity helicopter. I am also pleased to share that Dr. Eric Fossum was recently named to the Forbes 250 list of America's greatest innovators. This recognition further highlights the extraordinary impact of his pioneering work and the power of engineering to transform the world. So if will Bo, Amy, and Sujay please join me for the formal presentation of the 2026 Charles Stark Draper Prize for Engineering. Eric?
Wow. So, thank you. Dang technology. So I wanted to begin my remarks by expressing my gratitude to the National Academy of Engineering and to the Charles Stark Draper Prize Selection Committee for recognizing the CMOS image sensor this year, and to my fellow image sensor technologists around the world that have over the past 30 years made this NASA technology bigger than Tang. So thank you. You have to be of a certain age to understand what I just said. Most of us are that age. The space age and the space race started when Sputnik was launched in 1957, as was I, so to speak, and so was Tang. For as long as I can remember, I've been excited by the space program. As I grew older and became a solid-state physics and device person, though, I sadly thought I would never get to be part of the space program, at least not until 1989, when I received an unexpected invitation from the NASA Jet Propulsion Laboratory to quit my Columbia faculty position and join them in Pasadena. Frankly, that decision took me about one heartbeat. Sign me up. I was joined by my second wife, Dr. Sabrina Kemeny. She's here, by the way. Sabrina, pop up for a moment. She's an important part of the CMOS image sensor story and is also my favorite former wife. She is one of my co-inventors also, and my co-founder, and was the CEO of our startup, Photobit, and also the mother of my two amazing daughters, choke up, who are also here. My family is, of course, very dear to me, as I'm sure your families are to you, and I'm so grateful to have them, and my genius mechanical engineer brother, Carl, gathered here today. Dang it. To help celebrate the Draper Prize. So now I want to talk about a few ways I wound up here. First on my mind is experiential learning, hands-on learning. In middle school, I was given an opportunity to attend a Saturday program at the Talcott Mountain Science Center in Avon, Connecticut, and I cannot tell you how much this experience shaped my future. This relatively small program, which served local Connecticut schools, focused on hands-on student involvement in the study of science. We each had our own study project, and we were mentored and nurtured by an amazing staff. And while doing a meteorology wind flow project, I also learned computer programming. And that was a new thing in 1970, especially for a middle schooler. And maybe, I think sometimes, if I was just a little smarter, I could have been Bill Gates. As it was, that incidentally acquired job skill served me very well and helped put me through college. I've remained involved and connected to the Science Center right up till today. In essence, it's part of the national STEM pipeline for the next generation. The U.S. is big on athletic pipelines for our youth, from Little Leagues, baseball, soccer, basketball, ice hockey, just to name a few. But we need to be big, very big, on STEM pipelines too. STEM may not be a match for every child, granted, but it's in the national interest to provide every child with such an experiential learning opportunity, just like we do with sports. And it's best done by letting them experience the cool and creative stuff about science and engineering in a personal, hands-on way. Programs developed by the NAE, Discover E, and the National Inventors Hall of Fame, such as Camp Invention, are great models of such energizing and effective engagement. So how can we further scale this STEM escalator so children of all backgrounds in America get a taste of hands-on STEM at a formative age? Because we cannot afford to let them slip by. Another choke moment. My wife of nearly 22 years, Susan Fossum, you can pop up for a moment too, is a former science teacher. And are they ever really former? That's an interesting question. But we are very strong supporters of Camp Invention, and we are happy to report that much of this generous prize will be used to support programs at the National Academy of Engineering and the Inventors Hall of Fame that strengthen the STEM escalator. So my life in the past 15 years has been about giving back what I can to the next generation, and it's the main reason I went to Dartmouth after 2 failed retirements. Okay, yes, I retired a little young. And thank you, Joe Helbley, wherever you are sitting, somewhere back there. Thank you, Joe, who's now the president of Lehigh University, for that opportunity. Joe's here tonight and was one of the recipients of the NAE Gordon Prize for creating the Dartmouth PhD Innovation Program and fellowship in 2008, which he asked me to direct in 2010. And I can tell you what a cool job I have to get to guide exceptionally bright PhD students who also want to learn about deep tech innovation and entrepreneurship. And I get to share my experiences in creating and leading a few deep tech startups. And there's currently about 50 plus PhD students in this first in the nation program at Dartmouth. I have other duties at Dartmouth, regular professor stuff, and some administrative leadership duties as vice provost. And most of the time, it's the best job ever. Well, next to working at JPL. So I want to close my remarks by thanking all of you for gathering to celebrate this night with me. In addition to family, I'm truly grateful to friends, old and new. President of the NAE, Sujay Liu, Undersecretary of Commerce and Director of the USPTO, John Squires, Chief Technologist of the NASA Jet Propulsion Laboratory, Dr. Sholai Niksad, Dartmouth Engineering Dean, Doug Van Sitters, National Inventors Hall of Fame CEO Monica Jones, Executive Vice President Rini Paiva, and board member Steve Sasson, inventor of the digital camera, and Talcott Mountain Science Center Board of Trustee Dr. Stephen Fantone, who's also an NAE member. I remember when I was 16 and doing programming work after school, my employer, Sandy Stever, telling me it's always better to be lucky than smart. And wow, it's so true, and gosh, I am really such a lucky dog. I am truly humbled and honored by your support, and thank you all so much. Thank you.
Well, I hope you've enjoyed this evening's celebration as much as I have. It has been a privilege to honor such an extraordinary engineer and to recognize his remarkable achievement. Thank you to everyone who participated and to all of our guests who joined us in celebrating the 2026 Charles Stark Draper Prize for Engineering. Now, dessert will be served in the West Court where the reception was held. Please join us there to continue the conversation and to personally congratulate the recipient, Dr. Eric Fossum. Thank you and have a good evening.